Alright, John, this is going to be the last and final video helping you with the portfolio assignment. So after you go through all these, then hand in your portfolios to Abby so that I can grade them, so that you can at least have that grade into the assignment book, which would be awesome. Okay, so the last one is number 20. And this, yet again, is something that you have not learned yet. So bear with me because I'm going to have to explain it kind of in a way that will make sense. Okay, so number 20 says, how many different triangles can be constructed given the parts that the measure of angle D is 50 degrees, C, or side C, is equal to 15, and side D is equal to 20. So obviously, for some reason, they're not using A, B, and C, so I think they're using B, C, and D, which is a little bit weird, but whatever. So I'm going to draw a triangle and label them B, C, and D. So the measure of angle D right down here is 50 degrees. Side C, which is across from angle C, is 15, and side D is 20. And the question says, how many triangles? How many triangles can you form using this information, given this information in this triangle? Well, this is what we call the ambiguous case. Okay? Now, you don't really worry about this, but the word ambiguous, I can't spell. Ambiguous. That word really means uncertain. Okay? If you say something to me and it's kind of ambiguous, I could take it a couple of different ways. Alright, so this is called the ambiguous case because if you are given these pieces of information, it's kind of uncertain. It's uncertain whether or not that pieces of information could make you any triangles whatsoever. Maybe this stuff doesn't even work. Maybe 0 triangles can be formed. Maybe only 1 triangle can be created using this information, or maybe there's 2 different triangles that could be constructed using this information. So it's called the ambiguous case because given the information, there could be 0 triangles, 1 triangle, or 2 triangles. Now, on your Regents exam, the multiple choice questions always have 4 answers, so they're going to throw a 3 in there as well. Just cross that off as soon as you see it because that's not possible in this case, okay? They're just trying to trick you. So just get rid of that 3. It's always either 0, 1, or 2. Okay? So thinking back to geometry, what you took last year, when you were doing geometric proofs, there were a couple of different ways that you could prove that something was a triangle or triangles were congruent or whatever. One of the ones was side, side, side. One was angle, side, angle. One was side, angle, side. And I think that there were more of them too. But there was one way, or there was one set of information that your teacher always said, never use this. This is a bad word. Don't use this. It doesn't mean that the triangles are congruent. And it was ASS, angle, side, side. Now, most of us 10th graders took our teachers at their word and said, all right, fine, whatever, we can't use it, and then kind of just forgot about it. Well, the reason why we couldn't use ASS was because it was the ambiguous case. If you use angle, side, side, it doesn't necessarily guarantee that you're going to have a congruent triangle. In fact, you might have no triangle, or there might be 1, or there might be 2 possible triangles that could be formed. Okay? So whenever you read a question that says, how many different triangles can be constructed? It's the ambiguous case. It's angle, side, side. Okay? And I'm going to show you exactly what to do when you run into questions like this. On your reference sheet again, there are 2 other equations that we learned. Law of cosines, and then right down here there's law of sines. The law of sines pretty much just like sets up a proportion about any triangle that you have. Apparently this proportion is true. So this is the side A, and that is angle A. This is the side B, that's the angle B. That's the side C, that's the angle C. So apparently, if you take, like in this case, 20, which is the side, and divide it by 50 degrees, or the sine of 50 degrees, that is going to be equal to whatever the angle C is, sine of angle C divided, or 15 divided by that. So you know what I mean? I'm trying to think of an example. What it just means is if you take the sine of any angle and divide it by the side across from it, then it's going to be the same proportion as all the other angles and sides in a triangle. I know that I did a crappy job of explaining that, but all you need to know is whenever you see how many different triangles can be constructed, you need to use the law of sines. Now, in your reference sheet, it has it set up with A, B, and C. When you're doing law of sines, you're really only going to use 2 of those together. You're never going to use all 3. And you really don't even have to worry about the A and the B and the C. You kind of just say that you set up a proportion. So the side length of a triangle divided by the sine of the angle across from it, so the sine of 50, that's going to be equal to another side length, which is 15 in this case, divided by the sine of the angle across from it. And this is how we use this question, or this equation, is because we set up a proportion and we know 3 of those missing pieces, and we're solving for this one. So what I'm going to do is cross multiply, and I actually can solve to figure out what C would be in this case. Okay? So if I wrote this out, it'd be 15 times the sine of 50 is equal to 20 times the sine of C. I'm just cross multiplying. And I want to get this part by itself, so I'm going to divide both sides by 20. So sine of C is going to give me some decimal. Let's see. 15 times the sine of 50, and you always want to make sure that you're in degrees when you're doing this, is that decimal divided by 20. So the sine of C is equal to 0.5745, etc. But I don't care what sine of C is equal to. I want to know what the angle C is equal to. So the angle C is equal to, and I can do second sine, second answer, figure out what the angle is, and that is going to be 35 degrees. Except for the fact that, think about what we just did, and think about what we had done in the other, in chapter 13 with trig equations. When you get to the end and you have sine of an angle is equal to a positive value, let's think about which quadrants that answer would be in. Sine is positive in the first quadrant and in the second quadrant. So we don't only have an answer in the first quadrant, we actually have an answer in the second quadrant as well. So that's 180 minus 35. Hit enter, and that's 145 degrees. Okay? So the reason why, whenever you see the words how many, the reason why you use the law of sines is because when you get down here and you say sine is a positive value, then sine is in 2 different quadrants. And that makes sense, because if we're talking about angle C as the angle of a triangle, it wouldn't make sense for you to have an angle of a triangle that's down here in the 3rd quadrant, because down here that's bigger than 180 degrees. And if a triangle only has 180 degrees in it total, then you would never have an answer that's in the 3rd quadrant. And you would never have an answer that's in the 4th quadrant either, because that's like, you know, 280, 290, 300 degrees. And you certainly would never have an angle of a triangle that's 300 degrees when the whole triangle itself is only 180. That is why we use law of sines, is because sines is going to give me an answer in the first quadrant and an answer in the second quadrant. So I have two possible angles that could be true in this triangle. Okay? Now, we still haven't answered the question of how many triangles. We figured out what our answers were, which is fantastic. We know that our answers are 35 degrees and 145 degrees. But in order to ask or answer the question how many triangles are possible, we have to think about the situation that we're in. Let me just come down here. Let me draw another triangle of what we're looking at just so that it can be a clear new picture for us. So we have this triangle and we labeled them B, C, and D. And we knew that angle D was 50 degrees, side C was 15, and side D was 20. So we just figured out that the angle C right here could be either 35 degrees or 145 degrees. So what I want us to do is figure out if this works. When you would have an answer that would say 0, that's when you get an answer of sine C is equal to like 1.57. And that answer obviously doesn't exist. That's when you would have 0 triangles that work, when you get something that does not exist. Okay? Now, what you're going to do is go through and figure out if these angles make sense in your triangle. Let's just take 135 degrees first. If this angle C was 135 degrees and that angle is 50 degrees, 35 plus 50, that adds up to a total of 85 degrees. Well, if the whole triangle is 180 degrees, that's fine. That means that we are left over with 180 minus 85, that's 95 degrees. We're left over with 95 degrees, so angle B could be 95 degrees, which is fine. So 35 degrees, that works. That makes sense within the triangle. And now let's look at 145 degrees. If this angle, if angle C was 145 degrees, and this angle was 50 degrees, that's 195 degrees in this whole triangle. That means that it's exceeded the number of angles in a triangle. So this one does not work. So therefore, how many triangles that can be constructed are possible? There is only one triangle. Your answer is one triangle that is possible in this case. And that is because one of those angles worked and the second one did not work. If this angle happened to work and make sense within the context of the question, then your answer would have been 2 triangles. But your final answer is just 1 triangle. Okay? If you didn't understand that, I'm really sorry. I'm going to go through the notes and explain it again, but at this point, I would just write down the work. I would maybe go back through this video and watch it again, and then hand in your portfolio. Okay? And I will talk to you tomorrow.